In this video, we're going to talk about how to calculate probability for a normal distribution using a table. So back before calculators came pre-installed with statistics buttons, in order to calculate probability or percentage in a normal distribution, you would need to rely on a standardized normal distribution table. And what that involved doing was calculating z-scores for all of the data values of interest, and then looking up the percentages to the left of those z-scores in a table. And that's what we're going to practice here. For these problems, the first thing we need to do is identify the mean and standard deviation, because I know that in order to calculate z-scores, I need the mean and standard deviation. So typically I'm going to read through the question, I'm going to identify any numbers and statistics vocabulary that they give me, and as I do that I'm going to pick off a mean, a standard deviation, and boundary values for the percentage that I'm calculating. If I'm looking at a normally distributed variable that represents the height of teenagers in the US, I might have a boundary that says what is the probability that a randomly selected high school student in the US is shorter than 67 inches, 5'7". So I would need to identify mean, standard deviation, and the boundary values from the problem. And then I would convert those boundary values into z-scores using the formula that we have for z-scores. And we know that a z-score is the data value minus the mean divided by the standard deviation. And what we're calculating is how many standard deviations is that data value from the mean. Once we've done that, we're going to draw a standard normal distribution, mark where our boundary values sit, and shade in the area of interest that corresponds with the probability we're calculating. We're going to use the normal distribution table to find the area to the left of each of the boundary values in our picture. And then we'll use the values from the table and our picture to find the probability of interest. And we're going to do 3 examples so we can see what this looks like. So our example says the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the probability that a randomly selected student scored less than 65 on the exam. So in the problem, I am told that my random variable is a final exam score. And I'm also told that those final exam scores are normally distributed with a mean of 63 and a standard deviation of 5. And this problem says find the probability that a randomly selected student scored less than 65 on the exam. So using probability notation, that's the probability that x is less than 65. And the first thing I'm going to do now that I've set that up is I'm going to convert that boundary value, 65, to a z-score. So I know that z is going to be our data value of 65 minus our mean of 63 divided by our standard deviation of 5. And I know 65 minus 63 is 2. And 2 over 5, I believe, is 0.4. You might check. I'm going to write that to 2 decimal places, 0.40. So in terms of z-scores, I'm looking for the probability that a randomly selected student in this statistics class has a z-score that is less than positive 0.40. And scrolling back up to my step list, I'm now halfway done. I've done steps 1, 2, and 3. Next, I'm going to draw the standard normal distribution and shade in the area of interest. So I know that my normal distribution is a symmetric bell-shaped curve, something like that. I know that this axis, because we're doing the standard normal, represents z-scores. And for z-scores, the mean of the distribution is 0. And then we're counting by number of standard deviations, 1, 2, and 3 in each direction. And I'm going to come here in a different color and mark where my boundary is. And my z-score is 0.4. So that's in between 0 and 1. So right about here. And I'm going to label that. And then I'm going to shade in the direction that represents less than. And less than means values smaller than. I know that this is this direction here. And the next thing it says is use the normal distribution table to find the area to the left of each boundary value. And you'll notice that our inequality was to the left. Values less than 0.4 would be to the left of 0.4. So I'm going to get my answer directly from the probability table. I'm not going to need to do any additional work because it's already a left tail problem. So all I need to do is find this z-score in a normal distribution table. And to do that, we're going to scroll down. And this might look a little bit different than yours, but the structure is the same. So you'll notice it says the standard normal distribution, and specifically it's cumulative, meaning it's looking at area under the standard normal, which is what we want. And along the row labels, we see z-scores out to 1 decimal place. So it's giving us the ones place and the tenths place for the z-score. And then along the top, we're getting the hundredths place for the z-score. So what we're going to do, I'm going to scroll back up, is I need to find the row for 0.4 and then the column for 0, 0. And because it's positive, I'm actually going to have to scroll down a page to the positive side. And so I want positive 0.4 and 0, 0. And those intersect right here. And so my probability is 0.6554. So the probability that a randomly selected student scored less than 65 on the exam is about 65.54%. All right, the next example says find the probability that a randomly selected student scored more than 70 on the exam. So we're going to repeat our process. We already have our variable defined. We already know it's normal. We have our mean and standard deviation. My probability statement, I want an exam score that's more than 70, which is a greater than. We're going to go ahead and find our z-score. So this is going to be 70 minus 63 divided by 5. So I'm going to do that on our calculator really quick. And we get 1.4. And I'm going to carry it out one more decimal place because I know that my table wants 2. So I'm looking for the probability that z is greater than 1.4. So looking at our normal distribution, was horrible, Mr. J. Try again. I'm going to mark my boundary value. So my boundary value is at positive 1.4, so that's between 1 and 2. So right about here. And then greater than means I'm shading to the left, or the right, sorry. I'm shading in the direction that my inequality points. Greater than points to the right, I'm shading to the right. And now we run into a problem. Our table only gives us values to the left. I need to rewrite my probability statement in terms of a value to the left. Well, I happen to remember from the last problem that this area here in this section is PZ is less than my boundary. And I know that the whole curve should add up to 1 or 100%. The table is going to give me the value for the red here. I want the area in the green. The green is the complement, so I'm going to rewrite my greater than statement as 1 minus the equivalent less than statement. Now all I need to do is go to the table and look up the probability for 1.4. And I'm going to do this one in blue. So positive 1.40. I go down to 1.4. I go up to 0.00. And I look where they intersect. And we get 0.9192. And I know that that can't be the part in the green because that's most of the curve. That's 92% of the curve. And my area out here in the tail is clearly not 92% of the curve. So let's check on our calculator. 1 minus 0.9192 is 0.0808. So a little bit over 8% of students scored more than 70 on the exam. Our last question says, find the probability that a randomly selected student scored between 60 and 65 on the exam. So we know our mean and standard deviation, we know our distribution's normal, and I know that my probability statement is between 60 and 65. And I've done the z-score for 65 in part A, so I don't need to redo that. I do need to do the z-score for 60. I don't have that one. So 60 minus 63 divided by 5, and that's going to give us negative 0.6. So negative 0.60. In other words, we are looking for the probability that a randomly selected z-score is between negative 0.60 and positive 0.40. 0.40 was the z-score for 65, which is our upper bound here. So we're going to go ahead and go back to our picture for the standard normal distribution, and I'm going to mark those boundaries. So I have one at negative 6, I have one at positive 0.4, So I'm sitting in this region here. This is the area that I'm interested in. And the table is going to give me two things. So the area to the left of negative 0.6 is going to come from the table. So PZ less than negative 0.6. And then I'm going to get the area to the left of the upper bound, which is PZ is less than 0.4. I want the difference between them. Everything lower than this is the smaller, everything lower than that is the larger. I want that region in the middle where there's no overlap. That's the gap between them. So what I'm going to do in the table is I'm going to take the bigger value, z is less than negative 0.60, and I'm going to subtract the smaller value, z less than, oop, I have that backwards. No one caught me because no one's here. Bigger value is the positive, 0.40, minus the smaller, pz is less than negative 0.60. We know 0.40 from earlier. We found that. That's 6554. And then we're going to go ahead and look for negative 0.60. So negative 0.6. And then I want the 0 column, which is this first column. So I know that I should be down here at 0.2743. 2743. And we get 0.3811. So in other words, there is a 38.11% chance that a randomly selected student scored between 60 and 65 on the exam. All right. In terms of showing supporting work for calculations where you're using a data table, you need to show that z-score conversion. You need to write the problem out using appropriate probability notation. Anytime you're working with the normal distribution, you need to include appropriately labeled and shaded picture. And then any extra calculations you need to do because it's not a left tail to start with. If you have any questions on how to read that standard normal distribution table or how to find probabilities from it, feel free to send me an email or drop by office hours. Otherwise, I'll see you in our next video.